In this video, we're going to be factoring. So if we look at our first example, we have 6x to the third minus 4x. So the first thing that we want to do is we want to take out anything that all of the terms have in common. And in this case, each of the terms has a 2 and an x in common. So we can take out a 2x, and that's going to leave us with a 3x squared minus 2. So now we have 2x times the quantity 3x squared minus 2. And we can't break down a 3x squared minus 2 anymore. And so this is going to be completely factored. Let's take a look at letter B. We have 3x to the fourth plus 9x to the third plus 6x squared. So we want to take out anything that all the terms have in common. And in this case, they all have a 3x squared in common. So we're going to take out a 3x squared, which is going to leave us with x squared plus 3x plus 2. And now we have a trinomial. So we want to know, is it possible to break that down? So are there two numbers that will multiply to 2 but add to 3? So numbers that will multiply to 2 are 1 and 2. That will give me like positive 2. And those will also add to 3. So I'm going to be able to rewrite this piece right here as x plus 1 and x plus 2. And I need to make sure that I bring down that 3x squared because that's part of my answer. And now I see that I can't break it down any farther. And so this is going to be our solution. So now we have fully factored that expression. So let's take a look at letter C. For letter C, we have the quantity x plus 2 squared minus y squared. Now this one can be kind of tricky. It might catch you off guard. But this is simply the difference of squares, as we see an a squared minus a b squared. And so we can do our difference of squares there, which means that we're going to go ahead and need to find the square roots of each of those. So we're going to square root each piece, and we're going to see that this first piece is going to yield us, by crossing those out, because they cancel each other out, we're going to get an x plus 2 for our first piece. And again, square roots and squares undo each other. And so we're going to have a y for our second piece. And so in order to write the difference of squares, we're going to need to have two sets of pieces where we put the first part first, so x plus 2 in both pieces, and then put our second part as the last piece in both pieces. And then for it to be able to be the difference of squares, one of them needs to have a plus sign there, and one of them needs to have a minus sign there. And we are finished with this problem because we can't break that down anymore. There are no powers and nothing can come out. So we're going to go ahead. So let's take a look at our next example. For letter D, we have 16x to the fourth minus 81. Now looking at this, the first thing I notice is there's no middle value. I have a leading coefficient and I have a whole number. And I also notice that 16 is a perfect square, and so is 81, and so is my power of 4. So I think I can use the same trick that I used on our last one, where I use the difference of squares. So I'm going to go ahead and square root my first piece and square root my second piece and get it set up. So I'm going to have a 4x squared here is my answer, and a 9 here is my answer. So now I will have my parentheses, and I will put my first answer first. So I'll put the 4x squared first, 4x squared, and then I will put my second part second. And then don't forget, one of them needs to have a plus and one of them needs to have a minus. But as I'm looking at this, I see again that with my second binomial, I have, again, a perfect square here, a perfect square here, I have a square there, and a minus sign. All the things needed to do the difference of squares yet again. So we're going to go ahead and we're going to square root our first piece and square root our second piece, which is going to give us a 2x and a 3. So we need to remember that we still need to write this first piece down again. We need to bring that down. That's still part of our answer. But now our second part is actually going to end up giving us 2 more sets of parentheses. With our first part, first, so 2x and 2x, and then we're going to have our 3 and our 3. And then remember that we need to have a plus sign for one and a minus sign for the other. And we are finally completely factored because nothing else can be broken down. So let's take a look at our next problem. Here we have x squared minus 10x plus 25. So we have a trinomial that has a beginning, a middle, and an end. So we're trying the multiply add trick. So we want to know what two numbers can you multiply to make 25? And the answer is 5 and 5. And we need it to add to a negative 10 though. Well, that would work if I make my 5's negative. Well, does negative 5 times negative 5 equal positive 25? Well, it does. So we have found our match. So we're going to have x minus 5 and x minus 5. So we can actually rewrite this again as an x minus 5 quantity squared because we saw it twice. And this is now completely factored, and it's what we call a perfect squares trinomial. So if we look at our last example here, we have 16x squared plus 24x plus 9. And it looks really good. We've got a perfect square here and here, except that we have a middle piece, which means we can't do the difference of squares. So there's a few different ways to do this, but one way that I like to do it, I call it my disco box. Some people might call it the window. So I create a box with 4 pieces. And I'm going to put the first thing in the first box. I'm going to put the last thing in the last box. But what are you going to do with these 2 leftover boxes when you only have one number left? Well, what you do is you take that first number and that last number and you multiply them together. And that gives us 144. So now we're going to do the multiply add trick here. We want to know what 2 numbers will multiply to 144 but will add to a positive 24. So right at the top of my head I see 12 and 12. I can use them both as positive, and when I add them I get a 24. Those are going to be the numbers that I put in my leftover boxes. Now remember that this first term had an x squared with it. So this technically has an x squared, which means each of the 12s has an x, which is why our green boxes have x's with them. So now what we're going to do is we're just going to see what the boxes have in common. So if we were to go and look at these boxes here, we want to know what number do those 2 boxes have in common? And the answer is it has a 4, but they also have an x in common. Well, what do these boxes have in common? They have a 3 in common. So we'll put a 3 there. Well, what do these boxes have in common? Well, those boxes also have a 4 in common, and they also have an x in common. And finally, what do these boxes have in common? And they have a 3 in common. So now we can take our pieces here and here, and we can write those into our parentheses. So we had a 4x, and we have a positive 3, and we had a 4x, and a positive 3. And it doesn't matter which box you write it in. And we notice that both of these pieces, these binomials, are the same. So we can rewrite them just the same way we rewrote example E. And this has now been fully factored. And this is also called a perfect squares trinomial. And you don't necessarily have to have done the box for this problem. That's just one way I thought about doing it.